After assigning the support, now what we do, we define the load and the load combination. So go to the load and definition option available here. After that, click on load case details, left click on it and click on add. Choose primary option here. Load number is 1, loading type. We are defining the dead load first. As the title is dead, you can name anything here, but it must represent a dead load. And after that, click on add. Similarly, we will add the live load. And a loading type is live. Click on add. For now, in this example also, we will use the dead and the live load only. In building, we will use dead, live and the seismic load. Click on close. Now let us define the loads inside the dead load. Click on dead option here and after that click on add.
Okay, save it.
Click on add. At first we assign the self weight. The direction is y and the factor is -1. Click on add. And after that the next load that we give is, let me show you. Okay. So here let us assume that these beams, these all 4 beams, this 1, 2, 3 and 4 beams, these all 4 beams have got a wall. This is our wall, okay? And let us assume that the load due to this wall is a UDL. If this beam is UDL, and let us assume that the intensity of the load is 10 kN per meter. While doing building, we will see how this load intensity can be calculated. For now, let us just assume this value. This is the dead load that we are going to apply. Let us apply 10 kN per meter load in these 2 beams. These 2 beams will have 10 kN per meter load, and in these 2 beams we will have 5 kN per meter. Okay. Now let us define accordingly. These loads are the member loads. So a left click on the member load and it is the uniform force. The force is -10 kN per meter. D1, D2, D3, they all are 0 because we are applying the load in the entire span of the beam. The direction is GY, that is the global Y direction, and the minus means the downward direction. Click on add. You can see a load definition has appeared over here. Similarly, next load that we define is 5 kN per meter load and click on add. Now we got 2 loads, 10 and 5 kN per meter. Let us define the live load that we are going to apply as well. Let us assume that this is our floor here. This is our floor. And on this we are applying the live load of 2 kN per meter square. Let us also assume that this is our live load, 2 kN per meter square. This is the intensity. And let us also assume that we got a floor finish of 1 kN per meter square. And this is a dead load. Here you have to see one thing, the Y range that this slab lies is, this is our 4 meter. This entire region is Y is equal to 4 meter region. Which means that if I take the region from here, okay, let me change the color. If I take the region from here up to somewhere here, like 5 meters, so this is 1 meter above our slab level. If I take the region from here to here, my slab will lie within this region. Is it? Yes, it is. Or what you can do, you can take from like 2 meters. This is 2 meters somewhere here. If I take from 2 meter to 4 meter, my slab will still lie in this region. To give these kinds of loads, you have to specify this region. Okay. Let me first define this dead load. For that, again, click on dead and click on add option. This load is a floor load. Save it. And the intensity is -1 kilonewton per meter square. Choose Y range option here, and here you have to define the range, define Y range, minimum and the maximum, which means that in Y range, which means that our Y range can be from 2 meter to 6 meters, 10 meters, 11, 12, any higher value you choose. We will only have this slab, we don't have any other slab. But suppose that if this is our building, okay, this is the ground, and we got the first floor at 4 meters, we got the second floor at 8 meter, we got third floor at 12 meters. In this case, for applying the load in the first floor, the Y range should be any value from 0 to 4 meters. That is, I can take 1, I can take 2, I can take 3, and any value that is equal to 4 or greater than 4 but must be less than 8, which means that I can choose 4. So Y range here is 3 meter to 4 meter. If I give Y range, then this floor will be selected. So if I give 5 again, only this floor will be selected because we don't have any floor here. If I give 6 again, only this floor will be selected. If I give 7 again, only this floor will be selected. And if I give 8, then this floor will also be selected because Y range, this direction is Y, and this Y range value will cover this floor as well. So this is the concept of Y range, from where to where you want to apply the loads. So here our Y range should be, let us take the minimum value as 2 meters and the maximum value as you can use 4 meter as well. So it will still select the slab. So take 5 just to be in the safer side. Okay. And similarly, the concept of the X range also applies here. We got only one slab. That is why we got a full X range. Okay, we got a full X range, but suppose that we got 4 slabs and this is 1 meter, this is 2 meters, this is 3 meters. Okay, in the Z direction, this is 1, this is 2, and this is 3. Let us just suppose that you want to apply 2 kilonewton per meter square load in this portion only. In that case, the X range is 1 to minimum value is 1 and the maximum value is 2, and the Z range is 1 to 2, minimum value is 1 and the maximum value is 2. And if you do that, only this portion will, or this panel will be selected. If you give the minimum value of X range as 2 and the maximum value as 3, for Z range, if you give the minimum value as 1 and the maximum value as 2, which means that this panel will be selected, and only in this portion the load will be applied. This is the concept of the range. Here, as we don't have any range for the X range because we are applying in the entire slab, we will give the minimum and the maximum values as 0, and same goes for the Z range as well. We click on add. Here you can see that you don't have any question mark in this load value, which means that you don't have to separately apply this load. Once you define the range and give the intensity of the load will be automatically applied. Now just click on close. If you want to see this load, what do you have to do? You have to just left click on it. You can see how the load has been transferred to the beams. The ultimate goal of defining this slab is to transfer the load on it to the beams, isn't it? Same thing is done by STAAD Pro without even defining the slabs. Due to this reason, we do not define the slab because defining the slabs is very complicated and it will take a lot of time, and that is why we don't model the slabs in our regular building projects. You can see how the load has been transferred to the beams and how the load has been applied on the beams. Now let us go to the live load and define the live loads that we are applying here. Left click on the live and click on add, and we are applying the floor load. We will define the live load of 2 kilonewton per meter square. Direction is global Y. The distribution is not one way, it is a two-way distribution. If you left click on it, you can see the live load has been applied and the live load has been transferred to the beams as well. Now let us assign the beam loads. For that we have to select the beams. Okay, let us go to, alright, save it. Let us go to the top view, that is view from plus Y, and we'll select these two beams. And once you select this beam, press Ctrl, and after that select this beam. Here we'll apply minus 10 kilonewton per meter load and click on assign. So make sure that the assign to the selected beams has been checked, and after that click on assign, and after that click on yes. Now you can see the question mark has disappeared, which means that we have applied the load. Now again let us assign the 5 kilonewton per meter load. For that select these two beams. Okay, and after that click on this load and click on assign, and after that click on yes. We have to assign the self weight as well, so click on self weight, and here we will choose assign to view and click on assign, and after that click on yes. And let us see the isometric view. You can see that the wall load has been applied. You can see the higher value at these two beams and the lower value at these two beams. After defining the loads, now let us define the load combination. For that, click on load case details, and after that click on add. Here we will define the load combination. As you can see that we have applied two kinds of load. Actually, yeah, two kinds of load, dead load and the live load. These two loads are not applied separately one by one. Okay, these two loads are applied simultaneously, and when we design our structure as per the limit state method, what we do? We multiply the loads with partial factor of safety so that we increase the intensity of the load, and also we divide the strength by the partial factor of safety so that we can assume that our strength is low, which is actually not. Our strength is high, but we just assume during the calculations, or by increasing the load and by decreasing the strength, not actually decreasing, we get a greater window of safety. That is the limit state of method. While defining the load combination, we multiply the loads with partial factor of safety and we apply those loads simultaneously. But available loads, we got the dead, and we will multiply this load with a factor of 1.5. Here type means how these loads will be added. We will choose normal option. Load combination will name it as 1.5. Let me give the bracket. Dead load plus live load. In RCC design, we got 13 kind of load combinations as per IS 456-2000. We will define all those load combination when we design our building. Here we will define only one kind of load combination just to see how it works. After you select this load, dead load, and give the factor of 1.5, just click on this option. You can see load case 1, AI factor is 1.5. Okay, save it. After that, click on live and give the factor as 1.5 and click on this option. So here it is, the factor is 1.5 for both dead and the live load. Click on add and after that click on close. You can see the load combination has appeared over here. Click on close. Now what we do, we go to the analysis print option. Select no print option, or you can print anything that you want to see. Click on add. You can see that we have added the analysis command here. Click on close and after that click on analyze and click on run analysis. So we have to save our structure. Here you can see that our structure doesn't have any error and also doesn't have any warnings. We will just stay in the modeling mode and click on done option. Now we have to give the design command to the STAAD Pro. For that, click on design tab and after that select the concrete option here. From here select the code if it is not selected by default and select the code that is followed in your country. Now let us select some parameters such as what is the compressive strength of the concrete, what is the grade of the rebars that is used. Let us select those parameters. You can see that a lot of parameters have already been selected and we'll just unselect them by clicking on this option. Many of these parameters are useful, but here we will use only two parameters, that is FC, compressive strength of the concrete, and click on this option, go option. You can also give the clear cover as well, but I will not use this time. I'll use this while we are doing the building. And also click on FY, main, that is the yield strength of the main reinforcement. Click on this option and also I'll use the FI sec, that is the yield strength of the shear reinforcement. And anything else that I need, not for now, and just click on OK. And now let us define these parameters and click on define parameters. FC that I'll be using is 20 MPa, that is M20 grade of concrete. The compressive strength of M20 grade of concrete is 20 Newton per mm square. If you convert to kilonewton per meter square, it will be 20,000. Give this value and click on add. After that, click on FI main. Let's use yield strength of 415, or you can use 500 or 550 as well. I'll just use 415 for now. 415 Newton per mm square in kilonewton per meter square, extra 3 zeros. After that, click on add. Similarly, FI sec, I'll use 415 123 41523 and click on add. And after that, click on close. You can still see that question mark is against the option that we just defined. This is because we have defined but not assigned. We will assign this in a while. Before that, let us give the commands to design the beams and the columns. For that, click on commands and click on design beam command and click on add. You can see that the design command has been added. Similarly, click on design column, click on add. Design column command has been added and click on quantity takeoff. It will give you the total quantity of steel that will be used in this structure. And click on add and click on close. Now select the entire structure. The grade for the entire structure is FC 2000. Select this. If you want to define columns of different grade and beams of different grade, then you have to define two FCs. Here I have used only one. You can define 2 FCs as per your requirement. And after that, click save it. Click on assign to the selected beams and click on yes. So FC has been selected, and also we will assign the FY main to our entire structure. So select the entire structure and use this option assign to the selected beams and click on assign and click on yes. Similarly, FI-SEC 41500, select this entire structure and click on assign, and after that click on yes, and design beam option, and we have to select the beams only. So what we do, we go to select and go to beams parallel to x-axis, and again we go to select, go to beams parallel to z-axis. We have selected all the beams. Now what we do, check this option assign to the selected beams option and click on assign, which means that these 4 beams will be designed as per the formula of the beam, and click on yes. Now select the design column and select all the 4 columns. Go to select, go to beams parallel to and click on Y option, and after that select assign to the selected beams option here and click on assign, and after that click on yes. These 4 columns will be designed as per the formula or the codal provisions of the column design. So guys, this is it for this video. I hope it was helpful, and I'll see you in the next video.